Here is your warm-up for today. So make sure you have 2 answers and you've got your grading utensil ready to be checked. So the first one, the key phrase here is the fact that it did say compounded continuously. So we're going to be using that PERT formula from yesterday. So that is P times E to the RT. And that's going to tell us what our amount is after that number of years. So the first thing we need to do is label our variables. So it said the principal amount was $1,500. The rate was 4.5%. And remember, you do have to change that into a complete decimal. And we do that by moving it 2 places to the left. So it should be 0.045. Make sure you don't have 0.45 there. That's a completely different number. And then time is the 15. Remember, the letter E is the button on the calculator we use, so you don't even need to worry about labeling that one. So we know that A of t, which will be A of 15, equals 1,500 times E to the 0.045 times 15. So again, this is something you're going to be typing into your calculator, whether you type in the exponent first and go backwards, or you type it in exactly as you see it. Whichever way you type it into your calculator, you should have gotten 2,946.0494 blah blah blah. Now the directions on here did say to round to the nearest dollar, so we're rounding to the 6. Well, the number after the 6 is a 0, which tells us to stay the same. So the answer would be $2,946. If you had the equation correct, you wrote this down on your paper, but this answer was wrong, then check with somebody to help figure out how to type that into your calculator so you don't make the mistake when you have your test on this. The second question said, how does the graph of y equals 3 to the x plus 1 compare to the graph of the parent function? Well, remember, the base, which is this number since it's connected to the exponent, doesn't tell us anything. That's the parent function. So we look at the other numbers in the problem, and in this case, there only happens to be a 1. So we have to determine what that plus 1 does to our graph. Well, the plus 1 is part of the exponent, so that means a horizontal shift. Horizontal is always the opposite, so since it says plus 1, that actually means a negative 1, and negative means left. So there are your answers to the 2 warm-ups for today. Checking your homework from last night. Again, if you missed 15, 16, and 17, make sure you get some help from somebody with how to type that into your calculator. This one, the directions did say to round to 4 decimal places. It didn't say to round to the nearest whole number, or 10th. 18, 19, and 20, you're simply telling what those letters represented. Principal, rate, and the time in years for PERT. And 21 and 22, you were simply plugging into the formula, much like what we did for warm-up. Again, if you're getting this part correct, but the answer is wrong, then it's how you're typing it into your calculator. And I'm sure someone in class will be able to help you with that. Number 23 was the word problem. So our principal was a fourth of her $1,200 paycheck. It wasn't the $1,200. So if you put $1,200 there, obviously, unfortunately, your answer is going to be wrong at the end. So you had to take a fourth of it. 1,200 times a fourth, or 1,200 times 0.25 if you turn it into a decimal, is $300. The rate was 6%, which means 0.06, and the time was 15. And then there's your equation and the answer to it. With this one, it doesn't tell us where to round to. Same thing with 21 and 22. If they don't tell you where to round to, then you've got money, which means you round to the 100th place, because that's the the last digit when we use money. We are working on section 4.2 today. We're going to be talking about what we call logs. Logs are also a button on your calculator, but we're not going to get there yet. And we're going to talk about their functions as inverses. Logs are a way that we can replace exponents. It's a different form to write it. So a logarithm is log base b, b for base, of x equals y, if and only if you can rewrite it so that the base to the exponent of y is equal to x. And again, we read this as log base b, or whatever number happens to be there, of x. Okay. To write an exponential equation in logarithmic form, we're going to use what we just saw up there, which is called the definition of logarithms. So our first example, we have 100 equals 10 squared. If you don't like seeing the 10 squared written on the right hand side, we can of course change it to see 10 squared equals 100. Now we go log, and then we look for the base. The base is always connected to the exponent, so in this case it's the 10, of the answer, which is 100, and that tells us what exponent it's going to be equal to, which is 10. So I know that if I took my base to this exponent, I would get this answer right here. Now, the one thing that you need to know is when you have a base of 10, that one won't be written. Just like if I have an x, I know there's an invisible 1 there, but I don't write it. It's the same thing with logs. If it has a base of 10, we don't write it because that's the assumed base. So this would just look like log 100 equals 2. Let's go ahead and do the next one together. Again, if it helps you, you can rewrite it to say 3 to the 4th equals 81. And then we go log, and then we look for the base. The base in this case is 3. Of the answer, 81, is equal to what exponent? So again, I know that if I took 3 to the 4th, I would get 81. So go ahead and try the next one. 36 equals 6 squared. Check with a neighbor to see if you think your answer is right, and then unpause this to check your final answer. So your answer for this you try. So we have log, and then we look for the base, which is 6, and the base goes on the bottom, of the answer equals our exponent, which is 2. You're going to go ahead and do 1 through 4 right now, writing them in log form, and then we're going to talk about number 5 and then have you do the rest of the practice problems. So again, go ahead and do 1, 2, 3, 4, check with a neighbor, discuss your answers, and then unpause this when everyone in the class is ready to check the 4 problems. Alright, so for number 1, we start out with, we're writing it in log form, so we need to write the word log. Our base is 9, so that goes on the bottom, of the answer 81, and that equals the exponent, which is 2. Number 2, even though it's a fraction, it works the exact same way. So we have log, our base is 1/4, so we put that towards the bottom, of the answer, which is 1 over 64, and that equals our exponent, which is 3. Number 3, we have log. Base is 8, so that goes on the bottom of the answer 512 equals our exponent, which is 3. And number 4, you should have log base 2 of the answer 512 equals the exponent of 9. Hopefully you got all 4 of those correct. Now 5 through 8 is different. They start in log form and we're going to turn them back into exponential. So we're going to do one together and then you're going to do the next 3 on your own. So on number 5, we look for the base, which is in this case this 4. I look for the exponent, which is always in the answer part. And I know that that should equal 256. So go ahead and try 6, 7, and 8. Discuss number 8 if you need to. Check your answers, and then unpause this to see if they're correct. Number 6, you should have rewritten as 7 to the 0 equals 1. Base was 7, exponent is always in the answer part, and then it's equal to 1. Number 7 should have been 8 to the negative 2, and that's equal to 1 over 64. Number 8, well, this one doesn't have a base. So hopefully you remembered that in a prior example we talked about what number the base is when it's not there, and that is a base of 10. So this one is 10, and again that's because there is no base right here. Not because this number is 10, but because there's literally not a number written like there is here, here, and here. So 10 to the exponent of 1 is going to equal 10. You probably have a good amount of time left in class, so make sure you work on your homework. If you have anything missing after you get that done, this would be a great time to work on it as well.